Hello everyone, welcome to this tutorial. In this tutorial, we will talk about the course region OSS replication with function compute. So here is the agenda. We will talk about the objective, the topology, and then come with the demo. Okay, the objective is quite simple. It's to provide a cross-region OSS replication. And currently there is two solutions. One solution is to use the so-called OSS import tools to manually schedule a task to one at one region and then try to use that command to copy the content from one region to another region because basically cross-region OSS content replication is not yet available. And alternatively, um, we will use the function compute, which is an event-based trigger to synchronize the file change from one source to another one. Here is the topology we would like to discuss. In this topology, we will involve several things. One, of course, we will get the uh, two bucket. One is the function compute source. It can be any region which has the function compute enabled, which is quite essential because without the FC, we have no way to enable it. Another bucket is the sink, which can be any region used to copy the file to. And we also need to deploy our function compute project in the same region as the uh, bucket source. Um, we will see that from the region. In this example, we will use the Hong Kong region and the Shenzhen region, which doesn't provide the native OSS replication. And when we create some files in the bucket, it will trigger the function compute event. And when the object is created or the object is deleted, this change will replicate to the sink. Here is the high-level step of the topology. First of all, we will need to create bucket in the source region, and then we will create a bucket in the target region, and we will then create a function compute service in the source region, and then we will create a function and then upload the code to the project, and then we will create a trigger based on the OSS event. Uh, The function compute also, because it's a function, it can accept some parameter. So in this example, we define three parameter. One is the OSS endpoint, which is the source OSS endpoint address. You can get the address from the OSS console. And the sink bucket, which is the target bucket name. When you try to replicate from the source to the target, we need to specify where the bucket we try to copy to. And then finally, the parameter is the sink endpoint, which is the target OSS endpoint. It can be the same region or different region, depends on your choice. Um, After we deploy those functions, below is the expected behavior. When the file is uploaded in our source bucket under the particular prefix, it will automatically replicate to the target OSS bucket under the configured file folder name. And also, when the file is deleted in the source with the particular prefix, you will try to delete the same file in the target bucket as well. Okay, so here is the demo time. In this demo, we will try to quickly implement all those object creation and the coding upload. And you will involve some coding, and you can remember this URL, and the link can be and the source code can be available from this GitHub project. Yeah. Okay, so right now we will try to switch to the um, browser to get the uh, admin control. This is the Iron admin console, and first of all, we need to create a different bucket. To create a bucket, you first need to have a iCloud account, and then go to the object storage page, and then click the create bucket button. You can give the name, and then also the region. Remember the region has to be with function compute enabled, and then you can click OK to create. And for the same thing, you need to create the bucket in your target. For the time being, we already create two bucket. One is the FC source, which is located in Hong Kong region. Another is the FC sink, which is located in the Shenzhen region. And to get the OSS endpoint actually we can go to the overview page, and then you will see that this is the endpoint for those different buckets. Okay, after create a bucket, we have to create a function compute project. We can go to the console, and then you can see the function compute is under elastic computing page. And you can go to function compute, and then remember to select the region which is same as your source bucket deployed. And then you can create a surface. You give it the name, and then do some description, and then click OK. And once you create a surface, you can go into the surface and create a required function. This is the page I created earlier to store those trigger. And in this page, you can see that the total usage of this project and the billable resources. And not to mention that the function compute is computed by the memory size plus the execution time. So it's quite scalable and easy to handle massive amount with predictable cost. Okay, so after we create the service, we create a function by clicking the click function. Uh, for our function compute, we can implement our logic in different language, which support Java 8, Node.js, and Python. And in this example, we will create a Java 8 project. And then you have to choose the trigger, which um, trigger the function to execute. In this example, because we want to trigger the function when the OS event is created, so the trigger type should be the OSS. And we give them name and the target bucket we want to working on, and the event we want to listen. So to listen those object creation and the deletion event, we have to select the object creation event and also the object removed event. Okay, and then for this triggering rules, this is the prefix I mentioned before. So if you don't specify the prefix, which means that every object you put into this bucket will be triggering this event, which may not be the result you want. In this example, we just want to trigger those files within the same folder. So we have to specify this as the prefix. You can also use the suffix as the triggering point. It's up to you to decide how to narrow down the triggering boundary. And then you give the name of your function call, um, and then you can choose the runtime you want. You can upload your code from the zip file or from the OSS as well. We call that we have to config our variable. So we need to specify our OSS endpoint and also those bucket name as well as the target OSS endpoint, which can obtain from the OSS page. And then you define your event handler. In this case, is the package name plus the class name plus the handler name. And you choose how much memory to execute the logic and how much time it can allow to execute. In this case, we just because the logic is quite simple, we don't need so much memory. And if the process longer than 60 seconds, it will terminate by itself. Okay, we already grant all the necessary access, and then we have to choose the permission we required. Simply click the authorize, and you will get it done. Okay, this is the way we create the logic. You get here because we upload the code. So Right now, we go back to our environment to see how to upload the code by our through the command line. Okay, this is the IDE I use. IntelliJ it can be any command like programming tools or the IDE. So first of all, if you check out the project, is from our GitHub. Actually, you can download all the source code mentioned in this video, and the command to compile is the Maven command to create a package. It will download all the necessary package dependency and then pack the jar files automatically. So it will locate at the target folder, and this is the file we have to upload. Okay, we also have another tools called FCLI, which is the tools which use the command way to interact with our function compute. So we have the FCLI shell, which will be an interactive shell. You can do the ls to list all the function compute project in this folder. And we create the sync project before, so we go to the sync. Okay, and then next step is we have to upload the code. Remember, we have to upload the code in compiled in different project in different folder. So this is the command we try to upload the code, and then it will take some time to upload to the function compute log. And when it is returned, it's okay. So we will go to the browser again to use the browser to test the basic function of the function compute. Okay, so this is the source and the sink. For the source, we can be we empty the folder first. Then to make sure the sink is also empty. Okay. And then we try to upload a file. It can be single file or multiple file. And in this case, we try to upload several files. And when it's ready, we jump. You can see that from the local folder, the source already contain all those files uploaded. And what about the sync target? We will see that the file is also there as well. This is the way how we replicate those incremental change to the destination. And also, in case we try to remove from the source, it will also automatically propagate the change as well. So in this case, we remove those files. So the target should only have the local.gif, the JPEG left. Okay, we will see that the result as expected. So this is the way how we leverage the function compute. In this case, you don't need to have a separate ECS instance to run those synchronization logic, and it's all event-based trigger and pay as you go. Hope you enjoyed this video. Bye bye.